This video is brought to you by mywayteaching.com.
See, from the recent study, we know that these molecules they constitute matter, isn't it? So the matter is made up of molecules. Molecules are nothing but yes, the combination of one or more atoms. We call it as molecule. Electron microscopes and even scanning tunneling microscopes enable us to even see them. Means we can see these molecules through electron microscopes as well as scanning tunneling microscopes. And even we can see atoms. The size of an atom is about an angstrom. You know what is angstrom? 1 angstrom is equal to how much? Yes, 1 angstrom is nothing but 10 raised to minus 10 meter. This is the size of an atom. In solids, we know that molecules are tightly packed. Atoms are, molecules or atoms are tightly packed in solids, and atoms are spaced about few angstroms, say 2 angstroms. In solids, the two atoms they are separated with the distance of 2 angstrom. So you can see how much the force of attraction is there between them, how tightly they are packed. Whereas in liquids, the separation between the atoms is also about the same. In liquids, the atoms are not as rigidly fixed as in case of solids, and the atoms in liquids they can move around, but in case of solids that's not possible. So this enables a liquid to flow. In gases, the interatomic distances are in tenths of angstrom. So in gases, we know the atoms are separated by compared to liquids and solids, they are separated by a large distance of about tenths of angstroms. The average distance a molecule can travel without colliding is called as mean free path. Okay, this is one of the important term, terminology, that is mean free path. This mean free path is nothing but the average distance a molecule can travel without colliding. This is called as mean free path. And the mean free path in gases is of the order of thousands of angstroms. Because in gases, we know atoms are separated by tens of angstroms, so they can travel a very large distance without colliding. So it is of order of thousands of angstroms in the gases. The atoms are much freer in gases and they can travel long distances without colliding. If they are not enclosed, gases disperse away. Whereas in solids and liquids, the closeness makes the interatomic force important, and this interatomic force has a long range attraction and a short range repulsion. Okay, the atoms they attract when they are at a few angstroms, but they repel when they come closer. If they are very close, then they repel, at few Armstrongs they attract each other. Okay. Even the static appearance of a gas is misleading. The gas is full of activity and equilibrium is a dynamic one. We already studied about this equilibrium concept. In dynamic equilibrium, molecules collide and change their speeds during the collision. Okay, first they collide and even they change their speed at the time of collision. Only the average properties are constant and remaining other properties will change. So we already know that atoms are not indivisible, or we can say elementary particles, which means we cannot divide them further. They consist of a nucleus and electrons. We already, the atom consists of what? Protons, neutrons, and electrons, isn't it? First of all, atom is an elementary particle, or we can say indivisible particle, and even it consists of nucleus. The core of the atom is nucleus, and electrons revolve around the nucleus, and this nucleus contains protons and neutrons. We call them as nucleons, isn't it? The nucleus itself is made up of these protons and neutrons, and the protons and neutrons are again made up of quarks. Even these quarks may not be the end of this story. There may be some striking like elementary entities. So there are a lot more things to study, research. Okay, and even we study behavior of gases as a collection of moving molecules in incessant motion. In the chapter, in the coming part, we'll study about that. What is that behavior of gases? Okay. There is another concept, or we can say it's an information, atomic hypothesis in ancient India and Greece. See, the average distance of a molecule can travel without colliding, that is called as mean free path. We just now studied about this, isn't it? Though John Dalton is credited with the introduction of atomic viewpoint in modern science, scholars in ancient India and even in Greece they conjured long before the existence of atoms and molecules. Before this, John Dalton he discovered that atomic theory. The thoughts were there in this ancient Indian and Greece period also. In the Vaishika school of thought in India, which is founded by Canada, Canada, 6th century BC, the atomic picture was developed in considerable detail. Atoms were thought to be external, eternal, indivisible, infinitely small, and ultimate parts of matter. In that school, it was already thought that atoms were thought to be eternal, indivisible, we can say elementary, infinitely small, Okay. And even it was argued that if matter could be subdivided without an end, there would be no difference between a mustard seed and a Meru mountain. And even they studied about the four kinds of atoms. We There is a Sanskrit word called paramanu for the smallest particle. It is called as paramanu. It is a Sanskrit word. Paramanu is a Sanskrit word for atom. Okay, postulated were earth, water, tejas means fire, and vayu that have the characteristic mass and other attributes were propounded. So these were the four kinds of atoms which were discovered during that time: bhumi, water, tejas, and vayu. Akasa was the thought to have no atomic structure, and it was continuous, and even it is considered as inert. Akasa in English we call it as space. Okay. Atoms combine to form different molecules. For example, two atoms combine to form a diatomic molecule, and three atoms form a triatomic molecule, isn't it? And even their properties depending upon the nature and even the ratio of the constituent atoms. The size of the atoms was also estimated by the conjecture or by methods that are not known to us. During that time there was some method to measure the size of atoms also. The estimates estimate is close to the modern estimate of atomic size. What they measured during that time is almost close in modern size also. In modern days what we are measuring, no, it is equivalent to that only. It is of the order of 10 raised to minus 10 meter. In ancient Greece, that is Democritus, 4th century BC, that is best known for his atomic hypothesis. Okay. The word atom means indivisible in Greek. Okay. According to him, atoms differ from each other physically, means in their shape, in their size, and even in other properties, and this resulted in the different properties of the substances which are formed by their combination. The atoms of water were smooth and round, and even they are unable to hook onto each other, which is why liquid flows easily. It was the Greek concept, what they thought. Okay. The atoms of earth were rough and jagged, so they held together to form hard substances. So they thought that the atoms of water are very smooth, so only water flows, whereas the atoms of earth are very rigid, so that they held the substance together. That was the Greek study. Okay. The atoms of fire were thorny, which is why it caused painful burns. So they considered atoms will differ each other from each other physically. These fascinating ideas, despite their ingenuity, could not evolve much further, perhaps because they were intuitive conjectures and speculations not tested and modified by quantitative experiments. Okay, but all these were not true, isn't it? We know the reason as per now. But at that time, whatever they thought, that atoms of water are very smooth, so only water flows, whereas the atoms of earth are rigid, so only water, the earth is very, no, the it is tightly packed. In case of fire, the atoms are made up of thorny particles, so only it causes painful burns. But all these are not scientifically tested, not even experimentally found. These are just some what we can say speculations which are not tested, or intuitive conjectures. So they are not based on any particular concept, it was just their assumption. So because of these only, their what we can say, that atomic theory could not evolve much further. Okay, this was about the Greece atomic hypothesis.